So welcome to Module 5, the Carboniferous swamps. The Carboniferous is the time period that follows the Devonian. And this module is part of the workshop Deep Down Paleobotany and Plant Evolution. So when plants started to spread out over the surface of the Earth. Oh, let's start here. So the time period that we're talking about is the Carboniferous. And the Carboniferous got its name because a lot of carbon got stored during that time period. It ranges roughly from 380 to 299 million years ago, and it is part of the Paleozoic. You might be looking at a diagram here that shows the Paleozoic and the Mesozoic and the Cenozoic eras, and you might be thinking, I do not see the Carboniferous. That is correct. The Carboniferous includes the Mississippian and the Pennsylvanian. So it's these two that we're talking about when I say Carboniferous, but it's especially the Pennsylvanian that we're going to look at, material that we're going to look at. So when plants started to spread out over the surface of the Earth, CO2 levels and temperatures started to drop. So earliest evidence for land plants was 470 million years ago. Plants started to radiate in the Devonian, CO2 levels started to drop, and because of that, the estimated global temperatures of our planet, here ranging from 500 to present in a million of years, our temperatures on our planet started to drop. That's indicated by this red line going down, ending up with these blue lines. Those blue lines include the Carboniferous, and we call this the late Paleozoic Ice Age. So by the Carboniferous, our Earth was in a ice-out stage with glacial cycles that went repeatedly from relatively warmer, so-called interglacials, to very cold glacial intervals. So the Carboniferous, especially the Pennsylvanian, is famous for its iconic peat swamps. And these included a lot of different plants, included seed ferns, tree ferns. Oh, going back, sorry. It included so-called seed ferns, tree ferns, gigantic horsetails, and conifer relatives that we call chordates. The lycopods are these big things. They grew in wetter areas on the landscapes, and they look like gigantic poles. The conifers were conifer relatives, and we have tree ferns that are similar to extant tree ferns in morphology. There were gigantic horsetails as well, and also gigantic dragonflies. So these swamps, they covered vast areas of the tropical region during the colder periods of this ice age. So during the late Carboniferous, all continents were collided into a supercontinent that we call Pangaea. So Europe and North America were lying side by side around the equator. So here I zoomed in. So we have USA over here and Europe over here. So together in the tropics. And that is why it's for a Dutch person like I am relatively easy to get trained in Europe and work in the same time interval in the US, because they had the same plants. So glacial and interglacial periods alternated each other. And during the glacial intervals, there were massive ice masses on the southern hemisphere, and because the ice was lying on the land, sea levels were lower during the glacials. So during the interglacials, part of those ice sheets melted again, ended up in the sea, and low parts of the continents, they drowned during those interglacial times. So as I mentioned earlier, our planet had two stable phases during the going through the Carboniferous. So glacial and interglacial stages. In the glacial mode, the continental ice sheets were relatively small. We removed them over here. There might still have been some. Sea level was high, and near the equator, the rainfall was monsoonal. And the intertropical convergence zone, that is a tropical rainfall belt, more or less during the year fluctuated from the northern part, more northern of the equator, to the southern part of the equator. So once a year it rained a lot, and there were also drier times the rest of the year. So in the glacial periods, the large ice sheets were covering the southern part of our planet, the South Pole. And because of that, sea level was lower, and also the tropical rainbow belt was more fixed near the equator. That means you would end up with ever-wet tropics during the glacials. So people think that one of those interglacial cycle took roughly 100,000 years. So now let's walk through one of those cycles. So going from a glacial into a glacial into an interglacial, but then on one spot of the planet. So this could be a landscape somewhere in the Midwest during the late Paleozoic Ice Ages. So we begin at the beginning at a glacial interval. Because the ice sheets build up on land, sea levels dropped, and most of the North American continent became exposed. Even here in this little square here left on the tropics, it's relatively cool and it's ever wet, so it rains all year around. Slowly, peat swamp forests started to form in the lower wet areas. These peats acted as a sponge, and it rained so much that the swamp started to spread. And before long, the peat swamp forest covers all of the relatively flat landscape. So thick peat layers accumulate in large part of North America. So there you have layers and layers and layers and layers of peat. Then, quite suddenly, Earth then switches into the warmer interglacial mode. The massive southern ice sheets begin to melt, sea levels rise and drown large part of North America that were relatively low-lying. Now on the bottom of this, what we call epicontinental sea, the thick peat layers are covered by marine sediments, and over time, the peats turn into coal. So the ever-wet climate changes to seasonally dry, and the swamp forests, they survive somewhere on the landscape in smaller patches. And that is what I'm showing in this next diagram. Just want to point out these glacial interglacial cycles happened over and over and over. So many of these peat and later coal layers formed. And it's actually this coal that we burned to warm our houses, to create electricity, and in Europe also start the beginning of the Industrial Revolution. So here we have the areas in North America that actually have massive coal beds, indicated here in green, but we're looking at what that part of the landscape likely looked like during the Carboniferous. The green indicates the areas with swamps. So you start here again with the cool glacial. You have a lot of peat swamp forest during that time. The planet warms up, the peat swamps, they retreat in small wetland refugia during the warmer interglacials, indicated here with green dots. And the sea level drops, then slowly the planet starts to cool again. The peat swamps spread out again, and rapid warming happens again. Sea level drops. I mean, sea level rises and the swamps survive in refugia. So these peat swamps are one of the best known fossil floras. Now, why is that? Why do we know these chordates, lycopods, tree ferns, horsetails, seed ferns in great detail? So I mentioned earlier that over time, these peat layers turn into coal. So we started out with a swamp. They produce peat layers. They get covered in sediment, marine sediment, and over time, under more pressure and more heat, slowly peat turns into coal. So that's illustrated here in this diagram on the right. So you start with peat, with all kind of plant material, all kind of, rubbish, more or less, plant remains. Over time, water gets squeezed out. A lot of the vital compounds disappear, and you won't end up with the coal that we use. So in this material, the coal that we have a lot of, you can't find fossil plants very easily anymore. But sometimes during those glacial phases, before the peat turns into coal, bits of the peat and the plant parts become encased in limestone, and we call this material cobalt. So it's a limestone within it preserved, relatively three-dimensionally and nicely up to cellular level sometimes, fossil plants. So we call these nodules cobalts, and here in the background you see a cobalt that has been sawed in two, and we're looking at rootlets of lycopods and a stem of a lycopod. And you can see, this is here at the top is a rootlet. And here you have a three-dimensional puzzle of a plant part that ended up in those peats. So we already saw several of the dominant plants in the peat swamps. We already saw one of those big lycopods, Lepidodendron, that produce. We saw some of those male spore producing cones. We saw a reconstruction of one of those big horsetails. So the Carboniferous peat swamps had plants in it that still have representatives today, but a lot of them are much smaller than they are now. But if you look at the plants themselves, they were dominated by entirely different plant groups in comparison to modern plants, which are modern swamps, which are dominated by mostly by flowering plants. So the big five are the lycopods, the tree ferns and ferns, gigantic horsetails, the group we call seed ferns, and they had fern-like foliage but produce seeds at the tips, and that is the term seed fern is a name that we just give to almost every seed plant that is not extant today anymore. And there were cordites. Those were conifer relatives with very, very large leaves. So here is a reconstruction of one of those peat forests. You can see that the tallest elements are the lycopods. They are emergent. Then the second layer underneath, there are lycopods. There are those gigantic horsetails, tree ferns, seed ferns, and those conifer relatives, the cordites. And on the ground, it was pretty crowded. The canopy was actually pretty open, but on the ground it was pretty crowded, and there were ferns, small horsetails, small herbaceous lycopods covering, and ferns covering the underground. So if we look at what we've seen so far in this module, it includes the really big lycopods, and they're actually part of the isoidalians. We still have those around, but they're relatively small. We'll show an example. And later on, horsetails, there were small ones, there were relatively big ones. You had the ferns, and you had seed plants, and there were already conifers around already, but they did not occur in the swamps, but there were conifer relatives and other seed plants like these seed ferns present in those swamps. So things are already starting to look more familiar, but a lot of the plants that are nowadays relatively small, like the lycopods and the horsetails, were pretty big. So the take-home points from this module, module number 5, Carboniferous swamps, is that during the Carboniferous times, Euramerica was located in the tropics. Glacial and interglacial intervals dominated the late Paleozoic Ice Age. During the glacial, ever-wet swamps dominated the Euramerican lowlands, and Euramerica was straddling the equator, so different than nowadays. And the coals from these swamps fueled the Industrial Revolution. You can imagine that a lot of carbon from the atmosphere ended up in those coals, which kept the planet cold. And we've been burning for several hundred years, some of that carbon, putting it back in the atmosphere again. So these coals were produced over tens of millions of years, and this is why it is risky to put a lot of that CO2 in the atmosphere back at the same time. But how to get it out, that's a completely different workshop. So I'm going to stop here, and there is time for questions.